Oh, there you go. Thank you. Okay, what would I do without you guys? So now we've moved on to introduction to trigonometric identities. Now, what is an identity? What does it mean by identical? Yeah, what does it mean like identical or it's the same, right? Yeah, it's the same. So we can think of it that way, right? So two different things, but then they would behave the same way. So in a trigonometry, what does it mean by a trig identity? So a trig identity is a trigonometric equation that is true for all permissible values of the variable in the expression on both sides of the equation. So it's going to be true no matter what. Sometimes it's written differently, but it's really the same thing, and we'll see that in later on. So we use trigonometric identities to simplify trigonometric expressions, and also it will help us later on to solve trig equations. Okay, so we're doing this to help us later on as well. So some of the identities that we've already been exposed to are as following. Sine theta is equal to 1 over cosecant of theta. Okay, so, or we can, what's the other possibility? We can say cosecant theta is the same thing as 1 over sine theta, right? If sine theta is equal to 1 over cosecant, cosecant is equal to the inverse of the sine, which is down here. Now what about cosine? Cosine is equivalent to 1 over secant theta, or secant theta is 1 over cos. Tangent is equal to 1 over cotangent, and cotangent is equal to 1 over tan theta. And then, so if tan theta is equal to sine theta over cos theta, cotangent is the reciprocal, be cos theta divided by sine theta. So these are nothing new to us. We've seen that before, right? Everyone's great. Now, here's the other thing that's true. So the reciprocal and the quotient identities can be arranged and written in the other forms. So if we say cosecant theta times sine theta equal to 1, well, how did that come to be? How did that come to be?
Multiplied it out?
Yeah, we multiply it out. So if this is where it's coming from, right? And what do? We cross multiply that. So cosecant theta times the sine of theta, that's equal to 1. That's basically what that is. How did this come to be? It's this cross multiplied. So secant multiplied by cos is equals to 1.
And one,
Cotangent, yeah.
one being the radius.
And 1 could be, yeah, you can think of it that way. Yeah. The radius 1. Okay. Now, here we go. Pythagorean theorem, Pythagorean identity. Well, what does that mean? Pythagorean identity. Back in the, a few booklets away, we said that we can figure out the cos of theta and sine of theta given the point on the terminal arm on that angle in standard position, and then the hypotenuse or the radius is 1. So this is where it came to be. So x squared plus y squared equals to 1. So if we take a look at that, we said the cos is our x and y is our sine. So if we go x squared, which is cos theta squared, and then y squared, which is sine squared theta, equal to 1. So that's, this one is the first identity that we're going to take a look at. So if you take a, I think, I'm going to give one to everybody. You're going to have this available to you, and some of you already have it, some of you, I will get one for you. So this one has some of the identities, or all of the, no, not all, some of the identities that we are going to be looking at. Now these ones that we just pointed out, they're too easy, it's not on your formula sheet, okay? But this one made it there on a formula sheet. So cos squared plus sine squared theta is equals to 1. This is our Pythagorean theorem identity. Now, so that's the first part. There are other Pythagorean identity in our formula sheet, and I'll show you these ones. So the first one on this, the other form, is tan squared theta plus 1 equals to secant squared theta, and 1 plus cotangent squared theta is equals to cosecant squared theta. So these ones are the Pythagorean identities. Pythagorean identities. Now, before I dive into all of these things and go on any further, what I'm going to do is I'm going to show you why this is true. We've already figured this out, that's true, right? Now what about this one? And what about that one? Why is that equal to secant squared theta? Let's see. So we know one of the identities is cotangent squared theta plus 1 is equals to cosecant squared theta. Okay. So why all of these is equal to that? Okay. So what we're going to do. Cotangent squared theta plus 1. Okay. Well, cotangent squared theta. Well, what's a cotangent again? Very good. Cos theta, cos squared theta over sine squared theta. Is everybody okay with that? Yeah, right? Because it's cos theta divided by sine theta. That's a cotangent, but then it's squared, so square for both. Plus 1. Okay, good. Well, what are we going to do? How can we add these two together? Yeah, lowest common denominator. And what's the lowest common denominator? Sine squared theta. So we're going to make it sine squared theta plus sine squared theta. Okay. So what we're going to do is we're going to multiply this by sine squared theta over sine squared theta. We're actually going to multiply it by 1 in this form. So what would it be? Cos squared theta plus sine squared theta. Okay, well now that they have the same denominator, I can write it in this way. cos squared theta plus sine squared theta divided by sine squared theta. Okay. Oh, what do we know about this one? Cos squared theta plus sine squared theta is equal to 1. Right, that's your first Pythagorean theorem. 1. So sine squared theta. Okay, well, what's 1 divided by sine theta? The cosecant, but it's squared, so it's cosec. I don't have to. Okay, 1 divided by sine squared theta is cosecant squared theta. Okay, so that's why it's called an identity, because although you started with something different, you know, you simplify it further or you work it out, it's basically the same thing. Okay, now let's try the other one. 1 plus tan squared theta equals to secant squared theta. So how can we show that these two are exactly the same thing? How can we show that this is really secant squared theta? So we're gonna start with 1 plus tan squared theta. Okay. So 1, oh, we can't do anything with 1 for now. We'll leave it as 1. What about tan squared theta? How can we rewrite that? Sine squared theta over cos squared theta. Okay. Now, how can we add these two?
Multiply the cos squared.
We need to have the same denominator when you're doing this, so that means I'm gonna go multiply by cos squared theta, both in the numerator and the denominator. Put it in 1 cos squared theta, so that's cos squared theta plus sine squared theta. Okay, how can I fix that? Can I simplify it further? Yeah, so the numerator is equivalent to 1. So 1 over cos squared theta. And then the reciprocal of cos squared theta is secant squared theta. Okay, so we've shown that that's true. Okay. So although it looks complicated, 1 plus tan squared theta, it really boils down to 1 over secant squared theta. Okay, now these things, going back to this, we can rearrange these things around. Okay, what's the other way that we can show the same thing? Cos squared is equals to 1 minus sine squared theta. So sometimes, or later on, okay, when we see 1 minus sine squared theta, we can use, instead of that, we can use cos squared theta. What's the other one? What if it's sine squared theta? What would that be? 1 minus cos squared theta. So later on, when we do the trig identities, when you see 1 minus cos squared theta, we can replace that with sine squared theta. Okay. What about this piece? Cotangent squared theta is equal to cosecant squared theta minus 1. Okay, so maybe when you see something like that, you can change it to that, or when you see this, you can change it to that one. What's the other one? Say it again. 1 is equal to cosecant square theta minus cotangent square theta. Okay. Can you write the other two version of this? So go ahead and write the other two version of that one. Is that okay? It's not too bad, right? Okay. So that's just trying to expose us with the Pythagorean theorem identities. Now, before we get into lesson 3, okay, we decided that we're going to move on to lesson 4 first. Okay, we'll go back to lesson 3 later. So let's go back. Let's go forward, not back, to lesson 4. We're going to see some examples in here. We'll go as far as we can, and then you have some examples for you to try. So it says here, simplifying trigonometric expressions. So many trigonometric expressions involve fractions. Remember that the denominator of a fraction cannot equal to 0, right? If the denominator becomes 0, what happens? It becomes undefined, right? Okay. So also the ratios tan theta, cotangent, secant theta, and cosecant all have values of theta that can cause the denominator to be 0, or it becomes undefined. The whole expression becomes undefined. So to those theta, values of theta, those are called the non-permissible value. We've had some experience with non-permissible values when we talked about rational functions. So it says here, example number 1. Determine the non-permissible values of x for these expressions. So what's a non-permissible value? So non-permissible value, cos of x equal 0. So we want values of x where this denominator cannot equal to 0, right? Not permissible. So what are the values that will make that 0? Which values will make it, cos of something will give you 0? Is that? Okay, we're looking for the angle. Yeah. Yeah. 90 degrees. Okay, so we can say 90 degrees, 270. Okay. And another 90. Okay, it could be negative 90. Could be negative 90. Could be negative 270. Okay, so it's from here. So from there and there. What? 4. Yeah. So what about in terms of pi? What would it be? It would be pi halves, 3 pi halves. Okay, it could be negative pi halves, it could be negative 3 pi halves. What's the general expression for that? What are the non-permissible values? So what's the general expression? So when we go from here to there, to there, to there, it could be pi halves. Okay. Now this is... Okay. Now we can do it in 2 different ways. I'll show you 2 different ways of doing that. We can say sine of x over cos of x, non-permissible value, x cannot equal to pi halves, plus or minus, or plus 2 pi times k, where k is an element of an integer. What's the other one?
3 pi halves.
3 pi halves plus 2 pi k. K is an element of integer. So these 2 together will take all of those points, right? All of those terminal angles. Now, can you think of another way so that instead of these 2, it'd be just 1?
Could it be just instead of 2 pi, it's just pi?
Mm-hmm. Yeah, that's a possibility as well. So you can say, or you can say pi halves plus pi k. Well, you should be asking in the back of your mind the 3-letter question. 3-letter. Why? Why? Yeah, so why? Why is that?
Half rotation.
Yeah, because you're going to get to that particular terminal angle every time you turn pi radians, or 180 degrees, right? So you can certainly write these 2, but here's the other way, which is much nicer, shorter way of writing the same thing, where k is an element of an integer. Okay, I just don't have a lot of room there. Okay. Or I could probably sneak it in here, so pi k, where k is an element of integer. Okay, now let's see here. Cos x divided by tan of x. Okay. Determine the non-permissible value. What's a non-permissible value for tan of x? Now we're probably thinking, well, how do you get a tan of x? Right? I'll just go over here because I'm going to not have room. Cos of x over tan of x. What's tan of x? Tan of x is sine of x over cos of x.
So it's cos x.
Mm-hmm.
Cos x divided by
Now this one here will make the denominator 0, right? So the cos of x will make the denominator, the value here that will make this whole thing 0 will make this whole expression 0. Okay, so now we're gonna ask ourselves, where is cos of x 0?
The same.
Where is cos of x equal to 0?
Say it's on.
There, and then there, right? There, and there. So we can say that's the case, then it's the non-permissible value. Okay, what's a non-permissible value? Non-permissible value where x cannot equal to
Pi half.
pi halves
Pi.
plus pi k, where k is an element of an integer. So far so good. So I'm going to write that down. So the non-permissible value x cannot equal to pi halves plus pi k, where k is an element of the integer. Okay. Anything else though? So that's going to be defined there. But when is tan 0? Okay. If the whole thing is 0, how can we get the whole thing equal to 0?
That one.
If this is also 0. Because if the numerator, if the sign is 0, then the doesn't matter what the cos is, the whole thing will be 0. So now we've got to ask, well, it's not just this one that we're wondering, it's about this one as well. So, where is sine of x equal to 0?
0 and pi.
0 and pi. Okay, so what's the way to state that these are my non-permissible values? X cannot equal to plus pi times k, where k is an element of an integer. Because the cos might not be 0, but the sine might be 0, which makes the whole thing 0. Okay, so that means, okay, can we simplify this? 0 plus pi k, which is really just pi k, pi times k, or pi times k, where k is an element of an integer. Okay. Now let's take a look at this one. This one looks like the most obvious of all the denominator, right? This is the obvious denominator. 1 plus sine of x. What will make that denominator 0? Let's take a look. Where is 1 plus sine of x equal to 0? That's if sine of x equals to -1. And now where is sine of x -1? sine is sine is the y coordinate, so it's right over here. Is everybody okay? Yeah? Anywhere else? No? Okay. So it's right there. So x cannot equal to what? 3 pi halves. Okay. Plus 2 pi k. And k is an element of an integer. Okay, so that's one part of it. Okay, so I'm going to put here x cannot equal to 3 pi halves plus 2 pi k, where k is an element of an integer. Can you think of another one?
Can you do it with a negative?
Yeah, we can have a negative, because if k is negative, then we'll just turn a negative rotation. Okay, can you see another one?
The cotangent?
Cotangent one? Okay. Yeah, so how can we make, well, my questions, you're right. Cotangent, okay. What makes us think that we have to consider the cotangent?
Can you make it 0 too? It'll make it 0 as well.
What's a cotangent?
So 1/10.
Right, because here, let's see. Cotangent of x divided by 1 plus sine of x. Okay, well, cotangent, what's another way of writing cotangent?
Cosine theta over sine theta.
Okay, so I can write that down as cotangent of x times, tell me if this is true, because sometimes this is going to help us figure it out. If I split it up like that, is everybody okay? Does that make sense to us, right? Okay, and you're right, cotangent is cos x sine x. Yes? Okay, now do you see what value or values of x that we have to consider that will make the denominator 0? So we figured this out. What's the other one?
Sine of x.
Sine of x. Yeah. Sine of x. So, we have to consider this one too. Well, where is sine of x equals 0? Because those are not allowed. Where's the sine of x 0? Zero, pi, 2 pi, right there, right? Okay, so where are they? So x cannot equal to 0
Pi.
plus pi k, where k is an element of an integer. Okay, simplify it further.
Pi.
It's just pi k. So here's the other one. So x cannot equal to pi k, where k is an element of an integer. So, okay, what's the moral of this story? What's the moral of the story? The moral of the story is that we have to look at the ones that we can potentially write as a fraction, because that one will make the denominator 0 as well. Okay? So, that's that piece. We're going to go to example number 2, and we'll go as far as this one. Okay. Determine, okay, this one, we're gonna scratch out the determine the non-permissible values. What we're just gonna do, 'cause this is can be convoluted here. We've already done it on example 1, so example number 2, what we're gonna do is we're just gonna use that as writing as a single trigonometric function. Can we simplify it further? How can we simplify this? Cotangent is cos of x over sine of x times sine of x. Okay. Can we simplify that further?
That must be close to that.
Okay. You know that the sine of x cancel, sine of x. So after all that cancellation, simplifies to cos of x. Okay. What about this one? Cos of x divided by cotangent of x. What's cotangent of x? Cos of x over sine of x. Okay, how do we simplify that one? Yeah, it's the same thing as multiplying the reciprocal. The reciprocal is sine of x over cos of x. Okay, is everybody okay with that piece? So when you're dividing, it's the same thing as multiplying the reciprocal. I'm making this darker. And then the cos of x cancels, so we're left with just the sine of x. Do you want to try letter C on your own? See if you can try it. What'd you get? Sine of x? Okay, very nice. Yeah? Did you get that? So I had to rewrite the secant of x as 1 over cos of x. I had to rewrite the cotangent as cos of x divided by the sine of x. And then sine squared of x, I just left at the sine squared of x. So the cos of x, there's a common factor that can be cancelled. And then the sine of x, one factor of that will cancel one of the sine of x. So the answer is just sine of x. You're good? Okay. These are baby steps, so let's take our little baby steps. So go ahead and do letter D. D is pretty fun. Okay, so what did you get here? 4D? Did you get sine of x?
Yeah.
Okay, so cotangent of x is gonna be cos of x over sine of x times tan of x, sine of x over cos of x divided by 1 over sine of x. So this is just 1. 1 divided by 1 over sine of x is sine of x. Okay, go ahead and try letter E. Did you finish? Oh, you did. Okay.
Something crazy.
Something
I don't know if I
crazy.
did it right.
Wait for E or D, F?
E.
E.
I'm sorry.
Let's see. Yeah. That's
Yeah?
what we got.
Tan of x? Okay. Oh, sorry. You spoil it to
Can you
people.
do it along here too?
Yeah, for sure. Okay, so let's take a look at letter
I
E.
didn't do F. I thought it was like those little prints at the bottom of the page. It was like when I missed that one question.
Okay, so let's do letter E. Secant squared of x. 1 over cos squared of x.
Or you can just break it up into one cos of x.
Hmm?
You can just break it up into one cos of x times 1 cos.
Oh yeah, you can do that. Yeah, you can split it up. The cos squared of x is cos of x, right? And then this is going to be cos of x divided by 1 over sine of x. Okay. Now this becomes the one factor of cos of x will cancel one factor of that, so we have just cos of x in the denominator. So I'll write it over here. 1 over cos of x divided by 1 over sine of x. And we're going to end up with a complex fraction. It's going to be 1 over cos of x. It's going to be 1 cos of x times sine of x over 1. So sine of x over cos of x, which is equals to tan of x. Okay, last but not the least, letter F. Hmm? Oh, sorry. Tan x. This one? Tan x. Tan of x. Yes, or what did you get?
For F?
For E or F? E? Okay, because I'm going to have these two cancel. So I'm going to have 1 over cos of x divided by 1 over sine of x. right? And then if I divide that, that's the same thing as multiplying reciprocal. So 1 times sine is sine, cos times 1 is cos, so it's tan of x. Yeah. Okay, letter F. Okay, so letter F, I had to write it in terms of cos and sine. So I can see that cos, cancel cos, sine, common factor, and I have 1 over sine of x, which is cosecant of x. Okay. Now, before we go away, actually, here, I'm going to take a look at this one in here. I'm going to revisit this one, because this one, I think some of these might not be true. Let's take a look. If we rearrange this, what would happen? Cos of x over sine of x over cos of x.
So it flips back up.
And it flips back up, so that becomes cos squared of x over sine of x.
That's what I eventually.
So, so the cos of x is not gonna affect it. So the cos of x cannot equal to 0. So we would have to scratch this off. So it's only the sine of x, the denominator, will make that 0.
And here's the pi k.
Just pi k. And I'll actually show you that on here. Pi k. Yeah, I'll show you what that looks like. Okay. Slide this thing in. So this one here, that's the function cos of x divided by the tan of x that I'm showing you on Desmos here. So we said it's going to be pi times k. So pi times k, if k is 0, it's going to be 0. If k is 1, it's going to be pi. If k is 2, it's going to be 2 pi. And if it's negative 1, it's negative pi. See, pi halves is not undefined here. It's going to give us 0, but it's not going to give us undefined. So we have to scratch that off. Okay? So, scratch off on your notes. We're going to scratch off this piece.
I'm glad you scratched off. I didn't highlight that other one. I just highlighted this one.
Oh, really?
Yeah.
Okay, so you probably deep down you knew.
I don't
Okay, so I'm going to stop right here, and that's a good place to stop. Tomorrow we're going to continue on. For tonight, there is no homework. However, you know what? If you could put in like 15 to half an hour working on that hand-in assignment of yours. I know it's due like
next week.
in a week and a half, right? It seems like it's a long time away, but you're gonna have assignments from another class, tests from another class, so if you can chip away every single day some of those questions, and go ahead and do that. So I'm not assigning anything, but do work on that big hand-in assignment.
Could be some math, damn it.
And you thought you could escape. Okay, have a good evening, everybody, and I will see you tomorrow.